Hello everyone. Today we will learn the requirements of excitation system of synchronous generator together. I am today's main instructor, Luo Qiang. As already analyzed, the tasks of the synchronous generator excitation automatic control system. These tasks are mainly realized by the excitation system in the conditions that the synchronous generator has been defined. The excitation system is composed of two parts, the excitation power unit and the excitation regulator. To give full play to their roles and fulfill the tasks of the generator, excitation automatic control system, the following requirements are put forward for the performance of the excitation power unit and excitation regulator respectively. First, requirements for the excitation regulator. As we know, the main task of the excitation regulator is to detect and synthesize the information of the system operation state to generate the corresponding control signal, which is amplified to control the excitation power unit to get the required generator excitation current. So its requirements are as follows. First, when the system is in normal operation, the excitation regulator should be able to reflect the generator voltage level to maintain the generator voltage at a given level. Second, fast demagnetization. Third, distribute reasonably the reactive power among the units and facilitate the transfer of reactive power. Fourth, for generating units with long-distance transmission, to be able to operate in a stable area, it is required that the excitation regulator does not have a failure zone. Fifth, can quickly respond to system failures with forced excitation and other control functions to improve transient steady and improve the conditions of system operation. Sixth, have a small time constant and can quickly respond to changes in the input information. Seventh, structure is simple and reliable, easy to operate and maintain, and gradually achieve the series standardization. Second, requirements for the excitation power unit. The excitation power unit is controlled by the excitation regulator. The requirements for it are as follows. First, sufficient regulation capacity. Generator in operation to maintain the system voltage or send reactive power are realized by changing the excitation current. So the excitation power unit should have enough regulation capacity to adapt to the requirements of various working conditions. Second, sufficient excitation ceiling voltage and voltage rise rate. As mentioned earlier, in terms of improving power system, operating conditions, and power system, transient steady, it is expected that the excitation power unit has a large forced excitation capability and a fast response capability. So in the excitation system, the excitation ceiling voltage and voltage rise rate are two important technical indicators. Excitation ceiling voltage is the excitation power unit in the forced excitation, may provide the highest output voltage value. The ratio of this value and the excitation voltage under rated operating conditions is called the forced excitation multiple, and the magnitude of its value involves factors such as manufacturing and cost, generally taken as 1.5 to 2. The excitation voltage rise rate is an index of the dynamic behavior of the excitation power unit, which is related to the test conditions and the definitions used. Generally speaking, during transient steady state, the time for the generator power angle to swing to the maximum value of the first cycle is about 0.4 to 0.7 seconds. So the average rate of rise of the excitation voltage in the first 0.5 is usually defined as the excitation voltage response ratio. As one of the important indicators of the excitation system, make a horizontal line AB at the starting voltage UEFO and then make a diagonal line AC so that the area covered by it in the first 0.5 second is equal to the area covered by the voltage volt time curve AD at the same time. In other words, make the area of the two shaded portions of the diagram equal. The excitation voltage response ratio roughly reflects the dynamic index of the excitation system, and the rise rate is used to define the excitation voltage corresponding ratio because in most cases, people are more concerned about the forced excitation effect of the generator. In fact, the demagnetization process of the excitation control system is equally important. Now, for the fast excitation system, its response time can be used as the evaluation index of dynamic performance. If the time required for the excitation voltage to reach 95% of the ceiling voltage is 0.1 second or less under the specified conditions, it is called a high initial response excitation system. The forced excitation multiple and voltage rise rate of the excitation system involve the structure and cost of the excitation system and other issues. So when choosing a program, we should put forward appropriate indicators according to the generator's position and role in the system and other factors to adapt to the operational requirements. Too high requirements may not be reasonable sometimes. That's all for this lesson. Thank you.